of material. The EPA's brought 40 pounds of carbon material for this session as well. So we got a lot that we want to cover, and so the sooner we get the session going, the sooner we can get into getting a lot of our questions answered and further align our efforts with how the government's moving forward. We're greatly pleased to have the EPA with us, as well as a representative from the Department of Energy. We have up here in the front, we have Andrew Fanera, who's director of the Energy Star program. He's been focused a lot, my interactions with, specifically around the data center area and storage. I know that he'll speak more about all the other programs that he has done. We have A.J. Howard here, and we also have Rich Brown, who's with Lawrence Berkeley National Labs, who's working in conjunction with the Department of Energy, dovetailing in with the Energy Star program. And so we got the core people that are driving the programs in the industry. Some of us for the companies that have servers have already worked this side of the agenda. I thought to get things going that we would just go around and do a brief introduction of who you are, who you're with, and if you want to say anything about green while you're here. So this will allow everyone that's a guest here for SNIA. I don't know if anyone's new here that's not a member of SNIA, that you're welcome here, and we'll just go on from there. We do also have a Polycom on, so if you have co-workers back at the office that want to dial in, they're welcome to do that and be part of this meeting. So I'll start off. I'm Wayne Adams. I'm on the board of directors. Been working with our Green Storage Initiative. I'm currently running the Alliances Committee, and I'm sitting in a couple other industry associations as well, and help work some of these relationships and pull these together. As my company is a large equipment manufacturer, and we have a vested interest in the direction that these programs are going. So,
Paul Boulay, Color Data Systems. I'm a hardware architect for them, and working on this on the green twig here, and also in the green grid.
Larry Lammers, VMware, Office of the CTO. I'm involved in our green initiative. I'm involved in several industry organizations. Obviously, green's a big part of virtualization these days, and so VMware is very interested in that.
Hi, Alan Yoder, NetApp. I'm on the technical council at SNIA and also on the Green Storage Initiative Governing Board.
we'll just stay on the side of the room here.
Don Goddard with NetApp. I'm the green hardware guy for NetApp, and I'm on the Green Twig and the Green Initiative here at SNIA.
Phil Mills, I am on the board of directors. I'm the secretary. Work for IBM, and IBM is a member of the Green Storage Initiative, so I'm here looking after that.
Tom Hammond-Dole, LSI. I'm on the board of the Green Storage Initiative within the SNIA. I also happen to be the vice chairman of the Fiber Channel Industry Association, so we're all looking at what we can do with green in the area there for efficiency.
Patrick Stankos, Sun Microsystems, member of the Green Twig, part of the former storage tech, storage industry. More interested about where we're going with green.
Kevin Shea from IBM, just listening in because I'm interested.
Rick Bauer, I'm the Technology and Education Director for the SNIA, staff liaison to the Green Storage Initiative, and Cub photographer.
I'm Yoshiki Kano from Hitachi. I'm engineer for the storage subsystem.
Way in the back.
John Malia. I'm the technology engineer for SNIA with the Technology Center. Just here supporting the event.
Both the U.S. stuff,
She knows better than to point the camera here. S.W. Worth, Microsoft. I'm on the board of directors of SNIA, the Green Storage Initiative Board. I wrote the first green storage tutorial that we delivered a year ago in April, and met Andrew at the Next Generation Data Conference last summer, and AJ and SNW in the fall, and we did some work around education.
I'm Jack Stevens with Gradient Systems. I'm a consultant at SNIA and focus currently on IC and ISO standardization.
I'm Patrick True. I'm a research staff.
Because of that, I have a very much special interest of this area. I'm just
initiative.
Okay, if you're out there and you need a copy of the presentation, you'll have to speak up. I was going to ask if someone would be kind enough to send it out to the email reflector. I think whose memory stick is on, we could give someone that's on the network and we can mail that out for people. Well, thank you everyone for taking a few seconds to identify ourselves. This is the agenda that I've structured. It may or may not work. The most important piece is that we're going to be here together for 4 hours. And so, don't wait until, like 2:30 to ask your first question. If you have something that's not making sense and you need to get it out, we'll have it interactive. But we do have a timetable that we'll also try to adhere to. So I was going to say limited interaction up front and with a very deep interaction at the tail end, but I don't want to say nothing's going on up until that point. So we're meant to get the information going as we need it, and it may also provide for richer discussion even at the tail end instead of going through some of the basics.
Someone just joined the phone.
Okay. Could you identify yourself that just joined the call?
Richard Flanagan, LSI.
Okay, and very shortly the slide decks are going to be mailed out to the email reflector for green storage that you'll be able to pick up.
Also Herb Ganser from HP is here.
Okay, hi Herb. All right, the first, what I've set up here is this first hour is information that's maybe redundant for some of us here because we've been living in the storage industry. But it's to help put a foundation in the building block that help EPA, DOE understand how close and similar is storage and how dissimilar it is from servers. And so that when we continue to provide information, we get on these data center tours and you hear end users talk about, that they have orthogonal planning decisions that they have to make to say, am I going for price and capacity or am I going for performance, which might have a higher energy consumption, that they got different business objectives and service level needs that they have. And us as a storage community, we're dealing in the bigger picture, and we've been wrestling with the simplicity of like the EPA and one number for all purposes isn't working out to our state and planning. So part of this is to get this foundation of information out in front of you. So we're going to go through, what's driving storage, what's driving growth, how it may become a bigger footprint in the data center, and who SNIA is, what we can do as an association, and then we'll break into what is all the diversity of storage, get into some of the basics of what are all the things that you see in the data center, and how they're used and how they're applied to accomplish business objectives. And then I get into how SNIA organizes itself to tackle green, and in a broader sense, what our companies are doing at the industry beyond what SNIA is doing, as setting a foundation. So that's where we're at. If some of this stuff gets to be redundant, or you've heard it before, that's okay. So, am I blocking the screen? All right, great. Thank you. So our industry association has been around for 10 years. We just celebrated our 10th anniversary. So some associations are still getting started, and equally on the other side, like so we've established ourselves as a worldwide organization. We champion an inflection point in the industry where we changed from direct attached storage to network storage, and it took off a lot of different constraints that direct attached storage has done. And since that point in time with these investments in network storage, it's grown into a lot of different dimensions, and part of what we'll go through is what they are. We are the primary industry association that represents all the major solution providers of network storage worldwide to educate the market, work on selected standards, and communicate best practices. So you've maybe come across us here in the United States and say, you're in San Francisco. Well, we're in Colorado. We're in Tokyo. We're rather distributed in Europe. We're in Australia, New Zealand, we're in Singapore, we're in China, we're in India. Each one of these geographies has its own self-standing legal entity with a group of members that are there. Many of them are subsets of the membership that we have here, plus local vendors. We also have technical capabilities in some of these geographies, so we have relationships with universities where there's professors that have provided lab space, where we do collaborate beyond just working on market development, where we do have the capability to take on some level of technical work. Our biggest technical operation is in Colorado Springs. It's a co-shared facility inside of an HP facility. We've been in this facility for over 5 years, and with basically a set of lab space and classroom space, and we've been conducting standards development, tool development, and interoperability programs and education programs. This allows like an association like us that drive a program to be able to say, take whatever you do on paper and have a place to go. Then you get into some awkward situations if you have to go to a member company to say, can I bring my competition into my building to work on a joint program with a lot of things that have to do with security, IT, and the ability to wall off a part of the building, which can be sometimes not possible, especially on a sustaining year-round program. And our technology facility provides that capability to take what we do on spec work and then actually implement it, test it, verify it, and validate it. So I don't have pictures of that here, but our website has that. So worldwide, we have over 7,000 members. These are individuals that represent over 400 organizations. In terms of what I would say, commercial organizations, there's about 150 that you could recognize by name, and you've heard a number of larger ones that are here that have, local representatives. I'd say probably about 80% of our membership is from the vendor community, but we also have end users that are part of our association, as well as channels and VAR suppliers, as well as people that deliver professional services in the areas of like system integration and educational services. One of our several missions has been to educate IT in the use of network storage, and to date we've trained over 10,000 people worldwide for education programs that we carry out in conferences, through special facilities, And we also have a certification program to raise knowledge sets of system and storage administrators so that they can be more successful in how they work with storage, independent of the vendors, technology that's there. Some other facets of this is that, roughly our operating budget's around between $5 and $6 million a year, and this allows us to afford a staff of 18 people, allows us to have these facilities that we run here in the States and programs that we run around the world. So I said we have these other geographic locations, and they conduct programs. They tend to feed off of the programs that we do here stateside. But in the area of energy, there's, since a lot of these regions have a very strong market development effort, they are familiar with some of the agencies that are driving regulation and new policy. And so, later in the discussion, when we talk about what the work you're doing in other geographies, it'll be important for us to understand so we can sort of work up a parallel with some of those geographies. So we do create some IP in the form of our specifications. This is adopted into our products, and these become our, we take our specifications and we make them ANSI standards first, and then we make them ISO standards, so it's going through that process. So we're committed to working with the global data center environment of the creative technology that global corporations can reference in their procurement programs on a worldwide basis. It's not a regional type of activity. Collectively, what our company membership represents and the type of solutions we deliver to the market, we represent about a $50 billion a year IT spend on a worldwide basis of what's being bought for storage and that. So we are the largest single industry association that's focused on network storage. And so, part of our value proposition, what we're saying here is that we bring everyone together, we collaborate, and we represent maybe a faster way to get to a consensus to work with the types of specifications that EPA has to put into the marketplace for us to meet mutual beneficial goals. Just as an example of technology specification work, we have 7 technology programs that are in different stages of life cycle that we write the spec, issue to our membership, take it to ANSI, then take it to ISO. The one program that's referenced as SNIA is one that's is the furthest along, where we're working on like the 4th and 5th generation of the specification. We're currently working on 1.5. In terms of adoption, we've taken that specification all the way through ANSI and ISO, and there's over 500 storage products from over 30 some vendors that have implemented that standard. So it's an interoperability standard to help manage a multi-vendor environment for the storage network. This particular technology is extensible where some of the work that's going on with the server space is being extended in the area of instrumentation for power management. We believe that in the storage space, this could be one of the technologies that we could extend and make an advancement in putting out power management capabilities into storage products. That would help on policy for what service levels that data center may want to follow. We've got a structure. I'm sure the U.S. government looks bigger, more complicated. About that, but probably one of the things that I understand is like we have a lot of technology programs that are structured here, so to be able to drive the 7 standards through the definition phase, we've got to break down and decompose some of the things that go on in the storage space because they're complicated solutions that include network components, storage components, post-computing components, and so we go through a rather rigorous process of developing our specs and so that we end up with quality specs that make a difference for the data center because they're all about uptime and never going down. I'm going to transition to what's driving the market, what keeps this industry association alive after 10 years. some associations come and go. They think of single technology. Our overall mission is about network storage. So, you know, if we ever get tired of the data center, we can go after wireless cell phones because there's a ton of storage in there that's dealing over the network, and there's a different set of problems there. And so we're talking about, like, you got the edge and you got the core, and so there's a lot going on in like the Web 2.0 environment, Web 3.0 environment that's driving a lot of edge content back into centralized environments, like the Googles and the Yahoos and the Amazons and other types of organizations that are building large data centers to support Web 2.0 infrastructure. So even though we think of like a corporation and its data center, it's like, well, it's a bank or it's an automotive company. There's these other type of businesses that are out there working off of the internet, e-commerce economy and related things that are also building large infrastructures and data centers. So from an IT industry, computers and data, you know, there's been waves of what is the structure of the physical equipment that is configured that supports what's going on. I got data and I want to turn it into information. And we're part of the IT industry that's about storage. We have to store it, we have to serve it up, and also then also restore it once it's been processed. And so this type of diagram represents waves of computing that went from single mainframe environments to client-server environments to this web-based environment. And as each one of these waves goes through a period of time, the amount of data, the amount of computers, and the amount of storage that's being applied to it continue to grow. And the importance and the availability of the data continues to grow as well. And so these become some of the various drivers that all fold into the general ecosystem of around the world of what's driving it. It's not one thing, it's styles and architectures of providing the enablement for how people could use that infrastructure to use it for business or use it for pleasure, and what drives that. One piece that continues to get more important is the value of data. 10, 15 years ago was about the value of the computer server itself, and there's data, but there wasn't as much focus on, if I lose the data, what does that do to my business? Today, if you lose your data or you can't get access to your business, the dollar per minute or the risk of it being lost is gone. That's probably one of the biggest service level propositions that all the vendors that they're serving in commercial space are driving at is protecting the data so it's not compromised and always making sure it's available. And if you do have a mechanical or IT equipment failure, that you were able to replace it on the fly without a disruption to service. So we'll get into like global instances of the data and the technology that allow that to happen. A lot of data that's being created, you've probably seen all different types of studies, the Berkeley study, this study, that study. You know, who's creating the data? Is it the banks? Is it our cell phones? Is it this? Is it that? It's all that. And it's growing at an exponential rate. So this is trying to state that, you know, we went back like 30 years ago. Most of the data being created was being created on paper. As computers become pervasive in everything that we do in our house, in our home, in our business, you know, studies have shown that all new data being created, 92% of it's digital. So that means it's going into IT equipment, and eventually that has to be stored, managed, and served.
As opposed to paper.
Yes, compared to paper.
I'm going to say if it's not digital, what is it?
You could be writing a check. I do, so, or typing up a paper, or something like that.
People don't do paper.
Or you think about like photographs. Photographs used to be a chemical paper process. That's all digital. That's all digital. So, as I say, like computer technology is like pervasive into all facets of things, and the data's going in as like that.
Data.
In terms of how vendors go to market and serve serve, who's creating the data or has to manage it. There's big companies, medium-sized companies, and there's a number of market research firms that put taxonomies on there to help companies understand how to go to market and serve their client. And typically, when you look at this type of segmentation, you can end up with different types of computer infrastructures that are best tailored to the size of that organization. Like with a Shell oil company needs to run oil exploration on a worldwide global basis and move data around the world. It's much different than Joe Smith's insurance company and a bond company that's right down the corner here, and who also is using computer technology, but he might have alliances with the bank that's in the background. So the total ecosystem has a combination of everyone being a networked environment, but in terms of the types of solutions and the size of the solutions, they sort of fall into these ranges. And so, these large organizations spend a lot of money, the smaller ones spend less money. But they're all buying storage of some sort, and they have different workloads that will warrant different types of investments in storage. So this is a trend of where's the data being created today, and the enterprise is like, years ago you had the mainframes creating the accounting data, and that was the extent of a lot of computing back in the 60s outside of what was going on in military defense and what they were doing. As we've moved forward, everyone has a laptop or other type of portable devices. The data is being created first time on that device, but data still has to be protected within the organization. It has to be transferred and stored in the corporate data center has to bring it in from the edge and also serve it back out to the edge. So even though these other devices are part of the total picture, all the data still comes back to the data center where you get efficiencies and scale in the data center, rather than having it out in a lot of open rooms like this that are scattered all through a corporation. This particular model is a complex one, trying to show a lot of different relationships and information at once. It's not the Rubik's Cube of our industry, but it tries to illustrate, coming back to that other triangle, here's the size of the enterprise and what type of solutions are being applied in that part of the enterprise, and what are some of the attributes that go with that solution. So, when you have small, medium businesses, mid-range, enterprise, what prices they may want to spend on the type of solution that's there. What's the type of recovery time that might be there? Financial institution has to be nearly immediate. The gas station may not need to have that way, so then we might be down in this space here. So we get into different technologies that work for different types of application segments in the marketplace. And the more layers of the engine you pull back on the storage industry, the vendors that create the solutions, you'll see that we have different things that might be building blocks that help scale a solution that won't say one size fits all, instead of having a design solution for each stratification. But we have both of those characteristics in our industry, where we have things designed specifically for the top end and things designed for the bottom end. And then some technologies that are designed for the bottom end that are meant to be aggregated together with added value software and connectivity to provide near equivalency of something that's designed for the top end. So some of the things that are on the front mind of IT data centers for storage and IT is server and storage consolidation, lower cost and complexity. You may have been in a number of conferences and you've seen companies that say, I had 30 distributed data centers, I brought it down to 4 or 5 data centers, and I went into that's what's called consolidation, and they go into a larger arrangement of servers, they virtualize those, and then they put out a large network of storage where you can have all these different virtualized applications accessing the data instead of everyone having their own dedicated storage. It's a more cost-effective way to manage the data, raise the utilization rates of the servers, and also raise the utilization rates of the storage. So like we have these dedicated servers maybe using 20-30% of the disk capacity. You move it into a network environment where it's shared and virtualized. You try and aim to get between 60 to 80% utilization in the disk storage systems. It goes want to leave some capacity for upside growth and fluctuations so you don't cap out and you can't solve the IT load. But so there's been anywhere from like 25, 40, 50% type of ROI paybacks by going from reducing the number of facilities that are in use, removing the number of people that have to manage all those places, and getting into efficiencies higher efficiencies of less capital equipment to do the same job. Virtualization is a big piece of servers. It's also, virtualization is in various different layers and flavors inside of storage. And so large storage arrays have been virtualized for many years in the form of how we take physical disks and present them as a logical disk. There's other ways of taking physical cabinets and aggregate those together in larger pools. But it's all about raising utilization rates up to reduce cost. And so less equipment, less power, and less facilities, less power. So that's sort of why we're have these out here. The network is key. It's here now forever. There's some techniques about security that are coming into play. Security adds additional computational complexity that takes power, but it's protecting the data so that it can't be compromised. We have new technology that's coming out that takes less power. Right now it's more costly than some of the other technologies, but as we see in industry, that eventually these inflection curves cross over each other and they replace each other, and you end up with more cost-effective technology that permeates all strata of that environment. Other techniques and best practices are about raising utilization rates up. Instead of like each application looking at some set of storage and doing its provisioning, thin provisioning is about aggregating all the provisioning against a common pool and sort of taking it out. It looks like there's more storage that's really not available, but it satisfies the needs of the policy for the application. So things that have come out of industry around green storage is, your work and the utility companies, it's all in the front news and headlines. We've seen it in your presentation. So there's more focus going into next generation data centers. How do I reduce the cost? How do I restructure my business between facilities and IT to manage the power when you're responsible for two different objectives? It's more about just, so we're doing technology, new applications. It's a lot of leverage and save power based upon new technology with it just because we got more data that's out. I consume more capital. But when there's new technology, things like the density of how much you can device, you're having a net zero data, more data with the more and not increasing your some of the drivers out there, these are things we're talking about, the vendors are talking about, analysts are out there, they research the publications, they build products and solutions. This is what we're about. Anyway, I raced through this everything our industry does, but I wonder if I've left a major, that's, I raced through this material that we should put on the table for everybody. Welcome some of the
Fixed, seeing it more and more. What do you mean exactly?
It's created that's not meant. So, like you take an example of it becomes this fixed content. You may look at your bank account and your daily data in that field of your daily balance.
So that's why it's associated with
well, there's certain things that drive certain verticals. Like in healthcare, you have HIPAA. You got to do medical records and just replace things. You got to keep them in place. You got to have that you got to manage. Securities industry and every conversation and transaction has been for 7 years. This takes a snapshot in time and say, really financially with our executive to be retrievable type of inquiry audited. So some of the data is changeable, but that it can never be changed. Once they go and change it, a new contract is not changed. So what the statement is there is that the growth is a lot of it's being done by the consumer level. All the pictures, music files, video clips, and being fixed content. There's fixed content in business that people value and manage, and that's where the growth, because a piece of data that's in the database account takes up this much space. That's a music file much beyond from audio. And then there's special storage solutions to provide immutability that can decouple the application data so that you don't even have to have the application to keep the protection on it. Working on that standard called that. We'll bring you down.
Wayne, I think is that even though we're aggregate data and manage it more efficiently, the growth of data exponential that we may net be able to reduce the drive or the power consumed data, even though we're growing so rapidly. The real key all the time for present.
Yeah. So there's some technology that help in that space. So you have a slide deck. You're going to have to send it out to everyone. So all of a sudden, copies of that. So it'd be nice if everyone's just using a reference pointer. That's like some of this technology in the area of storage when you get into a high. It's called deduplication. But that provides that to reduce the amount of storage. We're dealing with an exponential growth of it. That's one example. My storage friends are all like bored out of mind.
Throw out an idea. Kind of relates back to your that show the different tiers of storage. I think there's something analogous to that. You might want to add a dimension to that, and that is a green storage standpoint that toward the top of the pyramid is very energy intensive, but as you move from kind of environmental point, you want it to be less and less energy intensive. Necessarily true for the in some cases, principle, I think, in storage, I think that's your kind of volatile memory be more energy intensive. Stuff you're holding for 50 years, using a lot of energy.
Yeah. That will also reference storage, right. You hear primary and offline. And then categories within the category. A measurement up here, it's down here, and vice versa. I mean, you've got different requirements, performance characteristics, and protection. Just they become more. Right. That's that study.
Some sort of parallel energy accounting, rolling that into the price thing should be rolled into the
right. It certainly affects the OpEx. I'm just thinking laying out this kind of for data storage dimension. You know, there's the price dimension, there's a recovery time, different dimensions, and another dimension in this framework is the energy.
I would prefer to think of that as a CapEx dimension, which is the price of the, and an OpEx dimension or a TCO. Those are TCO. I mean, one of the things that trying to end with you guys is, do you really expect for energy accounting, or able to, you know, to look for that into a pricing system?
Well,
I don't.
Well,
I'm doing, you know, carbon units.
Well, there are companies interested in that. But OpEx isn't included here, right? I don't know if your price.
No, I think most of those are capital expenses and not TCO, right?
So, in that level, right, would be energy itself would be.
On this is low at the top, at the bottom, because the line is not consuming energy except for.
I guess it's just looking forward and future storage architectures. Design principle.
Yes.
Or design that is, I mean, obviously, sort of eliminate energy consumption throughout the chain. That's, you know, that's.
Take my tape and put this out in the Arizona sunshine.
I would say except for the.
I mean, there's environments. I mean, there's some that call with the tape, even if it's just sitting and maintaining the environment for it.
It's high, it's low, but it doesn't go to zero. For any storage, that power and cooling.
Sure. Even for
You know, we've re-aggregated some of our thinking to something that's elegant. Like we've been deconstructing, like looking at what would be. We don't have any, but that's I think that, you know, our timetable match. That's more discussion this afternoon. But, okay, I'm going to, speaking over to Al, give us some basic about what is some story that we hear and see and how it's connected, and what does it do, what's it. Thank you.
I like standing right in the... No, it's fine. I'll move around lots. Okay. Mentioned, I'll go give kind of a storage primer over enterprise disk. Storage actually has a lot of, you know, disk, tape, flash. You know, even if you go back to the punch paper tape, it's really low storage. Disk, and it seems to be where a lot. And hopefully this will be beneficial to you. Visits here in a couple of weeks and see. That's what the intention was. But also dangerous to give any type of from a room full of if storage, I mean the obvious, sorry, disk. That's the basic fundamental. And within the disk, thing we want to find out is there is actually a wide variety of same. The one that goes, if you happen to have a meeting inside of it, is dramatically different than the enterprise drives. And even with computing environments, you've got computers that will use desktop drives versus the enterprise. Points and different characteristics in capacity in terms of the power. That's a secondary characteristic. With the today has a lot of focus on function. Things such as performance. When you talk about enterprises, those are driving performance and reliability. How quick can you get data on and off? How quick can you? How reliable is the drive in terms of failure modes and soft failure modes? For example, one of the biggest things on the next slide. For example, introduce performance for enterprise. Fast you spin to spin. 10,000, 15,000, all fairly common. Right now it seems to be a wall, although a gentleman here might but the faster you spin it, get out of the drive. It increases the energy consumption of the drive itself. So you 1,000 and 10,000 used in very rare that you'll see a 15,000 type machine, and almost guarantee you, unless you have some really over do some crazy. Another thing that we look at when we look at the interface is not some of the costs, and also interfaces like fiber channel, reliability and distance capabilities built price, some of our effectiveness, you get down to the safety capabilities. And knows that drives just, it wasn't too long ago, gigabyte hard drive was a pretty, it's not too hard to go down fries and get. I guess I should mention this last thing here because I mentioned reliability. From an enterprise drive standpoint, and the starts and stops. The start is something that to affect desktop drives or laptops. But when you talk about enterprise environments, using those capabilities, that becomes a thing to consider. You could very quickly, for example, see the number of starts and stops spec on an enterprise environment if you try to get down drives and spin them up. That's some other creative data management. And but it takes extra work. It's just you have to be very, very aware of. A typical storage device. This is the enterprise class storage device. This is kind of the components you're going to see. Drives themselves, the physical disk drives, typically have multiple ways into them. The disk drives can be grouped into units that are then presented out to the server. You'll have typically a controller, storage device itself. The controller functions as well as it may have cache. There's a lot of communication in the cabinet between the controllers, the cache, and the drive. Then typically you'll go out to some type of fabric, and that fabric might be fiber channel, internet-based increasingly, and then talk to servers. On the other end of it, they very often will have supplies in it, again trying to get the redundancy. Maybe 220, 110, some of them may be DC, especially from increasingly some data centers are looking at DC power supplies. The power is typically not singular. If you systems, you may have a singular power supply. You talk more about power systems, multiple tiers inside of it, or power redundancy inside of it, capability inside of the system as well. Cooling itself is also another pretty significant of energy inside of the device. I mean, if we talk about percentage drives themselves, they're the big users. The next thing probably fans, and then miscellaneous energy losses.
The order of magnitude, like a storage array that disk drives, and they have stuff doesn't scale single disk drive, and I just thought, how do I make a data in there by these controllers in there fast, latency and issues that such as this drive is. So using move the data fast to work at it, so very elegant. So even though underneath your desk, refrigerator or that work together with the storage device. When you get into network protection, then you get and start complexity.
Also means network for people. Okay. Yeah, network. A comment that fabric is. I think we can store fabric, but it's very similar.
Actual hardware, I mean, there's.
Oh yeah, right. Absolutely.
So there's like.
I'm sorry. Did you have a question?
That one.
Oh, logical unit number.
That's like that's this first order of virtualization physical disk drive of what it would have for, and then you're presenting it different to disk A or B, but it has that define the physical characteristics. The size of some of these drives, like say you may have 11s, you may define it with fine noise. Then there's other smaller capacity drives that make that gives you a whole different performance here in the transaction processing thing. You don't want to have a mechanical disk all the way in, so you take capacity that you have to go like still create that same logical unit of storage. The application's looking at it.
Things that you mount on goes up as G colon or something. As opposed to just it looks like
Four drives are like one drive. Back on in the mid environments, the most common one is channel, increasing low Ethernet. That's become in this particular space. But the two you really and as you get lower, sometimes you get a simpler system. Some other things such as SCSI.
So is the storage fabric considered part of the storage?
You know, it's a good question. Shops that I've visited, especially larger storage guys, want to have, and I've heard people are somewhat resistant to ones because as long as it's fiber network guys stay away from it, right? Yeah, and it's kind of affecting that.
Cable, got the little pie chart about networking, and that's.
Those were your numbers.
Those
Exactly. So you can answer that question.
Environment, there was no network.
Yeah, well, I guess it more servers and storage, looking at networking. And so with the storage,
The power efficiency of the drive.
In that case, you're talking about the internal connection, right?
Right.
Inside you control it well. And I think the hand skewing rates tend to be higher as well. But getting back to the fabric, the network, the storage network, the way you have to think about it is it is a separate network. It has different goals and objectives than the compute network itself. You may have some distance issues, like if you have either city-based mirroring capabilities or even across geography. That all comes into play when you talk about the network.
Yeah, even if it's an IP network, it'll very typically be a separate network. Not connected to the internet.
Right. Or connected to the data port of the computers. And that's done to, again, they have different goals and objectives.
In the storage fabric space, you will also see that there's like a mid-range class device and an enterprise class device. And the enterprise class device tend to have built-in redundancy and power and other type of batteries related things to keep it going. Whereas the mid-range, you use different methods to get high availability by putting the different units and the different power supplies. It's a different strategy, and when you get into the largest, it doesn't scale as elegantly as something that's been designed for the enterprise, even though you could functionally get there with either style configuration.
Just conceptually, a couple of differences. Storage networks are by nature, don't talk to strangers, and guaranteed in-order packet data delivery, packet delivery. Messaging networks are promiscuous, and they don't care whether they drop packets or not. In fact, that's how you do congestion control. Right. So there's not necessarily a lot of energy or power related or cooling related issues in there, but there's a great deal of differences in how you design protocols and even physical structure.
One of the questions back to your team here is that as you look at like the local networking, wide area networking part of the data center, is there like a particular focal point that you're going to that's like that represents itself as a trade association or a standards body that you're looking at as contrasted to just going down to Cisco or something?
Yeah. It's more concentrated in this case. I mean, there are obviously other standards bodies, but
we're not aware of any that have that focus on, like here's all the network vendors sitting there, other than at the very basic level, working on protocols or subcomponents like IEEE or IETF or something like that.